Hi, my name is Toney, and for my IME 400 project, I worked on an independent study with Chipotle for a simulation project. So first off, why would I work with Chipotle? When you do simulations, you want to have a lot of different factors. You want to be able to look at several pieces of it to really give you a full project, a full simulation to show out all the outcomes. The second thing about it is that it's easily seen and understood. It's not some obscure factory line from company X. It's a restaurant. People understand a line and stations to make food, and it's pretty easy to see it, grasp it, and understand it almost immediately. The other thing is that it's a system that is easy to time and measure. It's not super chaotic. It's not a build as you go kind of thing. It's very much a pull system in that they get one order and they take that order and they finish it, and then they take another order and continue to go. So it's easy to time each station, the number of people in the line, how time between arrivals, that kind of thing. So secondly, the scope. So I went into Chipotle and spoke with the manager about this project, and we talked about areas that would be viable to explore in a simulation, and I talked about kind of helping his profit margins a little bit. And he said, well, I don't really see how you could do that. And I said, well, we can do in IME what we do when we don't know where to start sometimes. We can essentially do a Pareto chart. We can find your biggest costs. So I asked him, what are your biggest costs? And he said, well, we really only have 3 costs that are meaningful. And they are maintenance, so costs like electricity and gas and other functions of the building, including rent. And then the material costs, which are the burritos, the steaks, the cups, everything like that. And then finally the labor costs. So I talked to him about the 3 costs, and the materials cost was really immutable. The rent doesn't change. They've rented the building for years now, and that's all they can do about it. The electricity they could try and cut down on by maybe ordering a new oven that was more energy efficient, that kind of thing. But nothing really simulation worthy. The material cost was apparently handled by a distribution center that distributes to all Chipotle. What it does is it makes deals with local farmers and growers, gets vegetables and meats and things like that from them, prepares them into packaged containers, and then ships them out to each of the Chipotles in the San Luis Obispo County. Also not really something I can help with unless I were to go broker deals with farmers on behalf of Chipotle. A little far out and not really applicable to a simulation. So I really looked at the third option, which was the labor force. So I said, well, isn't it summer right now, and doesn't your numbers go way down? He said, oh yeah, no, in summers we make far less money than we do during the winter and the spring. Or the winter and the spring and the fall, which is basically when school's in session. So I said, okay, well, what if I look at simulating your restaurant and focus just on your line, and we see if a smaller line is able to essentially provide the same level of service as a 5-man line, which is what they had now. And as I was watching this line and talking to him, I realized that there was a lot of idle time for these workers. They didn't have as many customers. They were moving very quickly and moving people out almost immediately, which is good. But when you have that much idle time and you can get the same performance with 3 people, I think it'd be better to save money. So I talked to him about it, and we said, what if we look at a minimum level for workers? And so we came with the minimum number of 3, 1 working the register, 1 working the heater, and then 1 working the in-between stations. And I started looking at that for my simulation. So I made some assumptions based on my time studies. I sat in and did about 20 to 25 hours of time studies. I timed how long it took certain stations to get their job done, the time between arrivals at given times, specifically between before lunch, during lunch, and then the dinner rush, kind of. And then I also looked on just the way that people moved through the line, how they made decisions, and kind of how that worked out. So these are the assumptions I came up with. The first one being no one skips steps in the line, so no one comes up, gets their burrito heated, and no one comes up from behind that person and says, I'm only getting a bowl, can I skip the burrito heater, and then skips that person in line and gets the next item. That never happened, so I'm going to continue to leave that as an assumption in my model. No one is ordering more than 1 burrito. This is not a totally accurate assumption in that sometimes people do order multiple burritos for friends who are not present in line, but my simulation accounts for that by making those people in the simulation, if that makes sense. So they're not actually physically there, but the simulation puts them there physically as though they were part of the line. So it still has to make 4 burritos, it just does it for 4 entities called customer, even if 3 of them physically aren't there. It's not a perfect solution, but it works. So no one decides to enter the queue based on psychological factors, so never once did I see someone step outside the restaurant, look around, examine the line very thoroughly, and then decide not to enter the store. For one thing, the line was never so full that really seemed like an issue to me. It's summer, and again, they have low numbers, so I don't think it'd be a problem. Employees that work the line will only work the line. This seems a little silly, but it's true. When they have employees on the line, That is quite frankly all they do. When talking with the manager, he said we only have 8 employees in the restaurant at a given time, maybe sometimes 9. And the usual structure is we have 5 people on the line. We have 1 cook. We have 1 miscellaneous, like a sweeper and soccer. He does anything that's missing. So if tables need cleaning or bathrooms need cleaning, or customers need helping, or the cook needs a little help, he does that sort of thing. Or someone on the line needs a break, he'll replace them. And then the manager does his job, which is a little bit of everything and some paperwork and number crunching and that kind of thing. I ignored the cook time and supply levels of the main ingredients. The main is referencing the beef, chicken, the barbacoa, and the sofritas, which is their new item. And I talked to him about it, and he said, "Well, you know what? In the summer, we never really run out because we have a really good supply system. They come every few days, and they give us a standard unit, and it lasts us much longer than it should because we have so few customers during the summer." So I never really worried about that. And even in my observation, in my 25 hours of time studies, I don't think I saw one person not get what they wanted because it was low on supply or something. The line maintains the same number of workers from open to close. This is also true until the last 15 minutes of closing, which is somewhat negligible, as in the last 15 minutes of closing, I've done that maybe 4 times, and all 4 times there were perhaps 2 customers left in the line. The profit margins for the product are not included in the study only because they were never given to me. When I asked the manager for explicit costs and profit ranges, he wouldn't give them to me. What he would tell me is that he wanted me to monitor. He asked if I could monitor, and I agreed to do so. What types of burritos are ordered and how frequently, and to keep special attention on guacamole, sodas, and vegetable burritos, because those 3 products are so cheap that they have virtually 100% profit margin. For example, if you go to Chipotle and you order any kind of burrito and you ask for vegetables added, they will add it for no cost, because to them it is quite frankly no cost. So how did I measure my output and my data? So with no real indication given on the profit margins, I wanted to see a total output per day at a best guess using just the cost of all of the items. So I've listed the costs and I've kept variables on them. Although I have values attached to these for dollar values, what I was mostly tracking for Chipotle was the number of particular items ordered. Part of his curiosity was seeing, what items get ordered most frequently on what days, or what is the most frequent item. And he explained that he had a very vague idea of how that works, just from observation, but no real hard numbers. So I looked into that for him. So if you look at the model, you'll see that I have a couple of bits and pieces, and I just want to go over them real briefly before I get to the results. I only have one entity, and that's a customer. They come into the line, they go through the stations, which are the locations. They have the burrito heating, they have beans and rice, they have a main dish, they have sour cream and cheese, guacamole, and they have a salsa, things like that, and then they have the cashier, and then they're out. Again, in my 25 hours of study, because it's the summer right now, I didn't look at seating arrangements. What I did do is I did a general view to see if the seating was ever full, and it was never full. It came very close to about 65% capacity a few times, but it was never full, and no one, not that I could see, no one left the store because it was too full. The third thing was variables. So I talked about those a little bit before, the T1, 2, and 3 being the reference to the chicken, beef, and barbacoa orders, to kind of give the manager an idea of what was being ordered and in what quantities. Lastly, the networks. So in Promado, when I built the network, I built it around the assumption of a 3-man line, because a 5-man line has no networks. They essentially work all the stations. I looked at how 3 people, employees, would split up the stations between themselves, and I built a network between those, and did this through some observations toward the last 15 minutes of closing, where they had 3 people on the line for the last 2 customers, because that's the only standby they have. So I looked at that and figured that out and kind of set up a network and used that for my model in the 3-person line. So the final thing was I included an attribute for the vegetarians so you could see them in the line. This was more for the manager's benefit than anything else, so that when I showed him the simulation, he could look at and see when vegetarians entered the line to see what frequency they came in with. I had data obviously from my hours of time study to show him, but it's one thing to say it comes in every 35 minutes, and then to see one in the line, the entity would change color. It would be red. So you'll see a customer enter the line, and sometimes you'll see a customer enter the line that is just a red color. That's indicating that they're a vegetarian. They're a little easier to serve as well because they will skip some of the positions in line. So here's the results. The most important result to look at is the labor cost. So labor cost is much lower than the next one will be with 5 people. It's $192 per day. The total profit is $1,753. Again, that number is somewhat skewed based on the results from because I'm using an inaccurate profit margin for each of the items in this list. If we go to the next list and we've seen a 5-man line, this is that the labor is 320. That's much greater, and the profit is actually quite a bit lower. Again, these numbers are not 100% accurate, but close enough to get the point across that making 3 people work would be fine. So to bring this whole thing to a conclusion, after 10 weeks of study and talking with the manager and doing my time studies and observations and running several simulations, I've come to the conclusion that it is much better for Chipotle to have 3 people in the line throughout the summer. And the reason I say summer is because these studies are not going to apply in the winter and spring and fall when school's in session, because I imagine there's a much greater rate of occurrence. If I go back a few slides, you'll see that if you add them all up, there's really only about, at most, 200 people who come in during the day. And that may seem like a small number, but that's actually very accurate to what's happening right now. They don't get a lot of business because SLO has a very great level of competition in the downtown area, and there's just significantly less customers, I would say, is the best way to put it. I mean, you got to imagine when the students come into town, they go down every other week or on Fridays or things like that, and these numbers would get much, much bigger when you have a humongous student population to add to that. So whether it's because the local townies don't like Chipotle or because it's the summer and there's no students, the fact of the matter is that they just make a lot less money during the summer, and so they need to adapt to that. And part of my conclusion would be to have an organic line where you should never get too stuck with having the same system all the time. And I know from talking to some locals and some students who have worked at jobs that one of the risks of working in SLO as an $8 an hour job, like a waiter or something, or a Chipotle line worker, is that you lose job security in the summer because they start to lay people off because they just don't need that many people. Okay, well, that's my project I was working on for 10 weeks, and I hope you liked it.